Okay, I'm just going to make a quick video today. Something that I thought about doing. It is we're going to talk about a tool, and we're going to stay with networks. I will be coming back to finish up the other network video. That would be the fourth of that segment. Today I'm just going to concentrate on basically we're going to be looking at. I have three modules on the schematic. I want to print the schematic. We have a 4-channel scope. We have the door module, as you can see, lower left, and then the relay module. Then there's the MICU, Multiplex Integrated Control Unit. They are all part of the BCAN network. We have 4 channels hooked up. We have channel A is a micro clamp, an AEMC K100, which I'll talk about. That is looped around the wire going into the door module. Channel B, the red channel, is right at the door module. Channel C is at our connector on the other side of the connector at the door module. As you can see, channel D, yellow, will start out at the relay module, looking at that's BCAN circuitry, and we will flip that guy later to the power supply to the door module and see what happens. I just want to tell you a little about this tool. It is a pricey tool. This was used, it's called an AEMC K100. They make a K110. It has like a 4 amp range, positive or negative. We're hooked on the wire. It's got two banana leads on it, and I've hooked it to the scope. It probably costs about $750 to $800 new, and I got it used on eBay. That's probably where you're probably better off, unless they come down in price, or maybe Snap-on, Pico, other companies start to make them. I don't believe it was designed as an automotive tool yet. It's very sensitive. So we're going to hook it to the scope. It has an attenuation of 1 milliamp equaling 1 millivolt. So let me make sure that, okay, 1 millivolt is 1 milliamp. That is correct. I'm going to put you to the scope now. We're not using a monitor today, just basically a computer on a stand. It's a 4-channel Pico 4425. We are at those 4 channels you can see on your schematic. Channel B, on the one going across the screen, is the current clamp. That is clamped on the wire going to the door module, and the other 3 are at different spots. On red and green are at the door module. Pre and post connector yellow is at the relay control module under the hood. And there's so many different situations I kind of want to talk about to see how advantageous it is to look at current on the network as we look at voltage, or use them both in harmony. I think it has a tremendous advantage to determine whether something is stopping the flow of current. We could have perfect voltage up into the network, up into the module, but something inside that module has kind of halted the flow of current, because current has to flow through a module for the transceiver to work, for the computers to give up their information and to receive information. This is a unipolar network. To my recollection, it can both receive and transmit. So basically, I have the key in my hand, and I'm gonna, like yesterday in the other 3 videos, I'm gonna hit the unlock button, and we have action, and we'll just kind of study it. Nothing's been disconnected. This is the natural state of it timing out. I will do it again. Hit the key and let it time out. Then I'm going to open the door, because that will activate the multiplex and that will start the network. Now we got action, and I'll stop the scope and we'll talk about it. Okay, let's take a look at. They got a high sample rate of 5 meg, because I really want to get a lot of granularity, especially with the micro clamp. We can see as clear as day we have action at the 3 spots on the module, and we have current flow right here. It's very. I'll stretch it just for the sake of better visuality. So basically, that is definitely tell us current flow. That means that circuit's complete. If you look at your illustration there, and you see the wires going into their particular modules, there's a transceiver in there that has to be able to flow current. If that were broken or open, the current couldn't flow. That's just basic. That's the way the electrical universe works. So we have to bear that in mind. This is a 1-wire network. I don't want to talk about. I'm not talking about CAN or high speed, which has 2 wires. We're going to strictly concentrate on 1 wire. And as we go through this movie, we can see our current flowing, and right there. And So that tells us that the circuit is complete. So what I'm going to do now, I'm going to start the car and start the scope, and we're going to see what happens. Okay, looks like we have current flowing. You can see it. Let's just say, for instance, as we look at our door module, that the beacon circuit opened between the green and red test point. So I'm going to open that up and I'm going to see what happens. Okay, well, as we talked about yesterday, red is kind of in distress. It looks different than green. That is the distress signal. I'll show you that just for grins. We'll take a look at that. We showed that in the other videos. That is distress. That module is crying out right there. We'll get back to the normal time. We're flat on the current. Now, we can actually, we've got to say the current's not flowing on that circuit to that door module, or coming from the door. It can't flow through because the circuit is open. I will start the scope again, and I'm going to, every 4 seconds, I will make and break that circuit, that beacon circuit at the door control module. And we're going to see what happens, see how the signals corroborate, how one validates another. Here we go. And I will stop the scope and we'll kind of analyze it. Okay, looks like we have the 4 signals. Blue looks like current is flowing here. We got a one thing about this tool, which I learned, it is it's not going to be spot on equal to the voltage signal. See, there's latency, there's other variables. I think they use a word like hysteresis. That's, you know, a big, not my kind of word, but as you can see, but the value of this tool, we have to say to ourselves, does it show something as opposed to nothing? That's why it really is a powerful tool, right? As opposed to right here, we can see how our distress signal and our no current flow is as clear as day. We got our distress signal up in red, and we got no current flow, because that's when the circuit going to the door controller module opened itself up. So let's get back to normal. And we're going to talk about power flow. So I'm going to take a little a change here. I'm going to take the yellow lead from the relay control module, and I'm going to put it on the power supply to the door control module. So let's take a look at this. That will go. Now we're up at let's go to 20 volts, because we're looking at system voltage on the yellow. Hope you can see that. Not the best color. I may make a color flip. I think that's a little hard to see. I'm going to do a color flip on 4. Sometimes you got to do this depending on where you're at with light. I'm going to take 4 and go to a different color. I'm going to go to the default color, which is sort of brown or bronzy gold. Now you can see that better. Okay. I'm kind of okay. So we got the system is stagnant. We're going to look at on gold, we got that's a hot feed to that door module. That's 12 volts all the time. And so let's start the car, get everything working. Okay, we got current flowing. We got system voltage on the gold. Let me pull it down so you can see it. That is our hot feed. We got a steady, we got a good 12 volts there. I am going to make and break that 12 volts and see what happens. And we'll take a look at the scope. And every 3 seconds, I will remove power from that module, and I'll put power back. Let's take a look at everything. Okay, I'll stop the scope and we'll analyze it. So power was coming and going at the relay control module. I'm sorry, at the door control module. Look what happens. Interesting. We've lost power, but we're still maintaining current. That means something is keeping, some other feed is keeping that module alive. And it's able to, for its transceiver to function, it's getting power from an alternate source. Probably if I looked on the schematic, I would be able to determine where, but nonetheless, you can see we lost power. Power went down. It's still able to the transceiver is still able to function. Okay, the car's off now. So let's take a look and let's go to the key, not start the car, but let's activate the door module via the key if I can find it. Okay, this is in the ignition. All right. I must have, yeah, I just activated it by pulling the key out. The multiplex unit probably recognized that, so these systems don't miss a trick. Okay. Okay. Now we still have 12 volts at the door mine. Now let me take the 12 volts away and see what happens. 12 volts went down. Now I'm going to activate the key. Nothing. No current. Nothing. Okay, the module can't make a request to another to wake up the circuit. But remember yesterday I was talking about another way that the circuit can wake up. So we got a low voltage where we're disconnected. We have no feed to the door module. Now let me open the door and close it. Now we woke the circuit up. But guess what? What can we surmise here? I'll do it again. Okay. Take a look at this. Okay. It doesn't look like we're flowing much current because we don't have power to the module. And let's see what happens when, in this situation, I'll start the scope and I'll plug the module, the power source for the door module back in. Much better on the current. You can see that clear as day. We'll stop the scope and run that back and we'll take a look at that. We'll see right when the power came back, the current came back, clear as day. It means that module probably went to sleep and with the ignition not running, was unable to start its transceiver and start to make this signal, to flow current through it, be able to receive and act normally. But anyway, that is current flowing through the door module. And I'm going to do one more thing. I want to go to the, I'm going to take that current source and I'm going to put it on a different module. I am lifting the AEMC K 100. I'm going to put it on the relay module and see what happens there. I will take the yellow scope lead. I will put it over back to the relay module also. So we're going to look at voltage at the network at the relay module and at the door module. So let's start the scope. And so the fourth channel, the gold channel, is now in network and everything's coming on. Network's coming on, current is flowing. Okay, I'll open the door. We can see current flowing when the door was opened right there. Okay, now I'm going to disconnect the connector at the relay control module, right at where it's the low amp clamp is placed, and see the effect on it. Okay. Looks like we don't have current there. I will start the car. Okay. Take a look at the screen. Yellow is on the beacon side of the disconnected connector. That's why it looks like a good looking beacon, because it's really picking off the beacon network. It's all one intact. The brake is at the relay control module directly. The low micro probe is at the wire going into the relay control module. I will make and break contact to the relay control module and take a look at the blue channel as I make and break contact. Okay, all right, let's see what we got. Okay, I'll shut the car off. Okay, we have no current flow when I broke the contact, but the gold guys still look good because that was on the beacon side of the network. Let me make a flip. I'll put the gold channel on the relay side of the connector and do the same thing. I will start the car. Okay. I'm going to stop the scope. We can see we're flowing current. We got high here. We got a good current pulses. I got a different scaling on the yellow, so let me bring that down to 10 so we get more uniformity in our capture. Okay. There we go. We're looking good on the 3 because the network is intact. I will make and break contact at the relay control module, and we'll see what happens. Okay, all right, let's see what transpired. I'll shut the car off. Okay, let's go back and roll back to when I'm, okay, we can see our thick, so we know what the thick guy means. That relay control module is in distress because it open circuited. It was able to make its distress signal right there. But since the current open, the wire, the feed on the network wire going to that relay control module open, it could not flow current. So if we had a problem internal to the relay control module and we had good voltage right up to the connector, right up to the wire going into the relay control module, we could determine that that problem is most likely inside the module. So basically, this AEMC micro probe, I think it has a lot of valuability. I've used it in other cases. I've used it on air fuel ratio sensors, key off battery drain, which I have a video coming up. A sensor checking how much a map sensor draws or a DPFE on a Ford. Every sensor, it is minutia, but it's still current. And this probe is real good at picking up very, very small amounts of current. Anyway, that should do it on here. Hope you're doing good, guys. Gary, I know you're a network guy. I'd like you to chime in on your opinion of the micro clamp, and hope everybody's well, and I will see you soon. Take care.